Last GMP is by Professor Idriss. He couldn't come, but he sent his presentations, slides, and I'm going to show it to you. I'm very proud that Professor Idriss finished his regression all the way from 0.01 to 10 seconds, and I'm going to show you the key change basically in his model. There are only several slides. I go fast. So this is the plot that you have seen, the ground motion recordings in the database. The only nice thing is that Professor Idriss reclassified this is based on California, green, lots of green here, and versus other regions in the database. And as you see, lots of green here and lots of yellow from China. So that's interesting, but the same concept that the others presented. Then he also he's showing the classification based on a style of faulting, strike, sleep, normal, reverse, oblique, normal, oblique, based on these colors, which again shows there are lots of green, blue here, which is basically reverse, that I think Norm also showed it. This is the equation. Is relatively simple, and the main change in this one is that he has VS30 scaling. He didn't have it before, now he has it, which is very important in terms of just getting the model to the national hazard maps, to scale it to 760. The selection of the data is free field stations, like most of us. He said that Chi-Chi main shock data is excluded for the time being from his selection. Recordings all the way to 175 kilometers, magnitude from 4.5 to 7.9, or possibly for application 5 to 7.9. And the GMPE, Idriss GMPE, is going to be applicable for 150 meters per second and higher. So this is his recorded, selected recorded motion. As you see, VS30 starts from 450 all the way to large VS30 values. That's the selected recordings for Idriss model. Then he has tables for all periods from 0.01 all the way to 10 seconds for magnitude 6.75 higher, and for magnitude 6.75 and lower. These are the residuals. They look nice based on the magnitude. I believe these are total residuals. He didn't say it, but I think that is it. Total residual versus magnitude, and total residual versus closest distance. No major trend. That these are for PGA. And then residuals base versus VS30 from 450 meters per second and higher. That's his selection range. And also no major trend in any of these things. The results are like this. The black one is Idriss 2008 model, and this red one is the latest model for 450. Remember, in 2008, he didn't have VS30 value. That's why he's comparing it with different VS30 value in 2012, 450, 550, and 900 meters per second. And in all cases, his 2012 model results in larger than 2008 model. The response spectra for pseudospectral acceleration for magnitude 5.5, 6.5, 6.5, 7.5, 1 kilometer distance. Same thing, but for 3 kilometer distance. He has not done smoothing yet, but the coefficients are available. And then same thing, pseudospectral acceleration for 10 and 30 kilometers. Again, he's going to do a smoothing on the response spectra. The response displacement spectra, basis period, obviously, for magnitude 5.5, 6.5, and 7.5. Again, for 1 kilometer on the left and 3 kilometers on the right. It goes all the way to 10 seconds. And the same thing now for 10 and 30 kilometers, displacement response spectra. And now he's showing it against different VS30 values for distance of 10 kilometers, magnitude 7.5, but for 450, 550, 760, and 1200 VS30 values. So the key change for Idriss model is that now he has VS30 scaling. This is, I believe, is the last slide, is VS30 slope, that the dots are coming from the regression, and he did a smoothing of the slope versus period. Now, if you have any questions and comments, he apologized he couldn't come today, but he welcomes any comments and any questions. I have his email address here. I am Idriss at AOL.com. I am Idriss at AOL.com. Any questions, comments are welcome. So this was for Professor Idriss model. I'm really proud to say that we have now 5 models with lots of pieces going to now converging together to get to the last point of that.